I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video we're going to take a look at exponential functions. Now an exponential function is a function of the form f of x equals a to the x power, where a is a positive number greater than 0, and a is not equal to 1 because that's not a very interesting function. 1 to the x power is just equal to 1. That's the constant function f of x equals 1. I've got an example here, f of x equals 3 to the x power. So if I wanted to find f of 4, I would raise 3 to the 4th power. And using a calculator, rather than multiplying 3 times 3 times 3 times 3, find one that has an exponential feature on it and raise 3 to the 4th power. You'll get 81. F of 1 is 3 to the 1st power, and that equals 3. And in general, for any value a, f of 1 is equal to that base a. F of 0 is 3 to the 0 power, which is defined to be 1. And in general, for any base a, f of 0 will always equal 1. F of negative 2 would be 3 to the negative 2 power, which can be rewritten as 1 over 3 to the positive 2 power, and 3 squared equals 9, so this is 1/9. Basically, the negative value in the exponent tells us to take that base into the denominator and raise it to the opposite power. F of 3/2 is 3 to the 3/2 power. Remember that 3 is an exponent, a power, and the 2 in the denominator is a root. So this is really the same as the square root of 3 to the 3rd power, or the square root of 27. Now, we know that 27 can be rewritten as 3 times 9, and we know the square root of 9 is 3. So this really is the same as 3 square root of 3. Finally, f of positive 1.78. I don't have a trick for doing that one. Here we need to go to our calculator. So let me open up Desmos. There we go. And again, I want to raise 3 to the 1.78 power. So I'm going to type 3. And then right here, there's this key that says a to the b power. I want to use that. And that moves the cursor up to where the exponent would be. Now I type in 1.78. Put on something so I can see what it says. I've got 7.067663001. You would need to be told how many places to round this to. I'm going to round this to the nearest thousandth, or 3 places. So that's approximately 7.068. Because we had 7.0676, we round that 7 up. All right, back to the exponential functions. The next thing we're going to talk about is how to graph them. And so I've got a table of values on the left-hand side for values of x ranging from positive 3 down to negative 3. When we put in positive 3, we raise 3 to the 3rd power. We know that's 27. 3 squared we know is 9. 3 to the 1st we know is 3. 3 to the 0 we know is 1. But as we work our way down that list, notice that each time we're dropping the exponent by 1, we're really dividing the function value by 3. So to go from 0 to negative 1, we divide 1 by 3, and we get 1/3. Divide by another 3, we get 1/9, and so on. We can see that as x gets more and more negative, those fractions are going to get smaller and smaller. They're getting close to 0 without actually reaching 0. That's important to know. On the positive side, we can see that when x is 4, we're going to get 81. 27 times 3. When x is 5, 81 times 3 is 243. So we can see those function values are going almost straight up the further out we go to the right. What we're going to focus on are these 3 values. When x is 1, 0, or negative 1. When x is 1, get out a. When x is 0, we get out 1. And when x is negative 1, we get out 1 divided by a. We'll put those 3 points on the graph. We'll also use the idea that the x-axis is going to be a horizontal asymptote. I mentioned that those fractions, as x becomes more and more negative, get closer and closer to 0 without touching them. And so that is a horizontal asymptote on the x-axis where y is equal to 0. So for this function, if you look from left to right, it's increasing everywhere. And the range is going to be from 0 to infinity, not including 0. Again, it can never equal 0, but it will cover all the values above 0. I want to use this to graph a function of the form a to the x minus h power plus k, where we're going to shift horizontally based on the value of h and vertically based on the value of k. That value of k will affect the horizontal asymptote as well. So the function we're going to work with is 2 to the x minus 3 power minus 2. And on the graph, I put 3 points that go with f of x equals 2 to the x, no shifting. So again, that was 1a, or for us, 1, 2, right there. 0, 1, no matter what the base is, 0, 1 is going to be on the graph right there. And finally, negative 1, 1 over a, that's going to be negative 1, comma 1 half. And I've got that right there on the graph. Also, the horizontal asymptote is shown with the highlighter on the x-axis. Okay. So what does the minus 3 and the minus 2 do? X minus 3 tells us that we're going to shift 3 to the right. What value is being subtracted from x is 3, and because it's a positive 3 we're subtracting, that's 3 in the right direction. If it said x plus 3, remember that that's just another way to write x minus negative 3. Negative 3 is being subtracted. That would be 3 to the left. The negative 2 afterwards tells us that we're going to be shifting everything down 2. If that was plus 2, it would be up 2. All right. The first thing I want to do is put the horizontal asymptote on the graph, and that shift of down 2 will move that horizontal asymptote down 2. Let's change the color. So that horizontal asymptote is, it's not x equals, it's y equals negative 2. Now we're going to take each point and move it 3 to the right and down 2. So starting with the point 1, comma 2, if I go 3 to the right and down 2, I'm going to end up at 4, comma 0. Zero, 1, 3 to the right, down 2 will get us to 3, negative 1. And again, that's 3 to the right and then down 2. Finally, at negative 1, 1 half, moving 3 to the right, 0, 1, 2, down 2 would get us to negative 1 half, negative 1 and 1 half. That would be about there. And there's a rough sketch of the graph. What else could we add? We could add the y-intercept by putting in 0 for x. We would see that that would be negative 1 and 7/8. We could add that to the graph and so on. We can tell from the graph the domain is all real numbers, but the range is from negative 2 to infinity, not including the negative 2. All right, so that's how you graph an exponential function using horizontal and vertical shifts. And just remember that the vertical shift affects both the horizontal asymptote and the range.